So it's a real pleasure to introduce Anna, and I know that a lot of people here are interested in climate change, and she's going to tell us about her research. Thank you very much.
Thanks. Good afternoon, everybody. Sorry, I suddenly seem to have got a cold, so I'm a bit croaky. Apologies. It's a real pleasure to be here with you today talking about some of our work on the Gambia, and to be completely frank, and showcasing what we've done with the idea that hopefully this will be a chance for us to think about collaborations going forward and potential work along the same lines with you guys here in Bristol. So I recently relocated from the Gambia to Bristol. Okay, so I'm going to talk a bit about what we've done so far, looking at the impact, and mostly we've been exploring the effect of extreme heat on maternal and child health. And then we have some few newer projects which are just at the process of starting up, which have a bit of a broader scope, looking more broadly at climate shocks. So those projects will include flood events, extreme precipitation events, as well as extreme heat. And yeah, very happy to kind of have more dialogue afterwards around the way forward. So for context, Gambia is the smallest country in mainland Africa. It sits in the west region. It's entirely surrounded by Senegal, and it's a low-income country. Its climate is Sahelian, so it has a long dry season and a short, intense wet season. And there's this really quite significant gradient as you move inland of temperature exposure. So the coast is considered the cool coast, although average temperatures are still around 28 degrees. But as you move inland, you're going up to seeing temperatures sometimes in the range of 45 degrees, 50 degrees in the extreme hot times. And when we look at the projections from the IPCC, we can see that West Africa, and particularly that area, is at very high risk of having many days exposed to temperatures above 40 degrees Celsius. So why is this important to pregnancy? This is from a systematic review where they put all together all of the studies that have been done by 2024, and you can see that on most of the outputs that they've studied, there was a harmful effect of heat. And the most studied outcome is preterm birth, but there are plenty of studies also looking at stillbirth and low birth weight, and much less studies looking at maternal outcomes, but beginning to create the evidence around severe maternal morbidity events, pre-eclampsia and gestational diabetes, all being at increased risk with exposure to extreme heat. But the point that this review was done, there was no data from low-income countries. There was one study, sorry, when I say no data, I'm talking about for the preterm birth. There was no data from low-income countries. There was a few studies from low middle-income countries, and there was at that point, I think, no data at all from Africa. So this kind of gives you a scope of where those studies are based from, and the majority of evidence is coming from the US and China. There is a scattering of studies coming from Africa, and a ring of studies now coming from what I consider kind of the at-risk regions, which is the tropical and subtropical regions, where we know there's a lot of extreme heat being experienced currently, but also forecasted to be experienced going forward. So I'm going to present some results now that haven't been published yet, so keep them on the down low. So one of the reasons why there was no data on preterm risk is that in many of the places where we work, there isn't a regular early gestational age dating, and so preterm birth is then very hard to accurately assign, and people have used a multitude of other things to sort of determine if a baby is preterm or not. And so this study utilised a prospective cohort called the PRECISE study, which is actually led from King's, and it was based in Gambia, Kenya and Mozambique. And you can see there's quite a variation in the climate, so that's the sort of mean monthly temperatures across the three countries. But this study was particularly important for us because they captured the women as they attended routine antenatal care, but they used what's called a tracer device to date the pregnancies. And the tracer device measures the cerebellum at the back of your brain, which is preserved throughout, the size is preserved throughout your gestational age development. So it doesn't matter if your in utero environment is challenging. So it doesn't matter if your baby is small for dates or anything like that, because that area of the brain is preserved. So you get much more accurate linking, understanding of what the actual gestational age is of those babies. And when we looked at, unfortunately, it does scan COVID. So there was a plan to recruit 10,000 women, and we have data on almost 5,000, with 17% were preterm. And I've done a time to event analysis on this study, where the time variable is gestational age. And there's a couple of key things that have come out. So first of all, I'll take a step back and just explain exactly what we did here. So every woman was geolocated by village of residence. We then took the global gridded climate data from the Copernicus climate data store, where you can access hourly data on climate, and we linked their geolocation to the heat stress. So we used the Universal Thermal Climate Index, which is a heat stress indices that takes into account heat and humidity. And then, having linked that, we then looked at the acute effect of heat exposure in the 7 days preceding birth. And women were defined as preterm as they came to the end of 36 weeks gestation, or they were censored at that point. And what's interesting here is that the hazard ratio is higher than you would find in high-income countries for those exposed to above the 95th percentile, which is often how we characterise extreme heat. But there is a difference in the age, with younger age group actually being more at risk than the older age group. And we're finding some evidence in some of the studies that I'm going to present later as to why this may be. At the moment, we think it could be around sort of thermo behaviour, perhaps adaptations options in the women. And what you can see here is the cumulative lag, and then the lag specific per day for those exposed to the 95th percentile versus the 50th percentile. So the key take home for me from the study is that we have now finally evidence that the risk of preterm birth in this population, which arguably is highly acclimatized to extreme heat, is still there and is higher than you see in high income settings. So the second on that list from preterm, where they sort of synthesized it, was low birth weight. So again, when I first started this work, there was very little data from this context on the link between extreme heat and low birth weight or intrauterine growth problems. And so again, using data from an existing study, so we used data from a trial which was on micronutrient supplementation, again linked to this ERA5, the global gridded climate data. We were able to map the heat exposure across pregnancy and the first 1,000 days of life, so going up to 2 years of infants, and link it to these serial measurements that had been done both in utero and then postnatally up until they were 2. And we sort of assumed that there are different effects of heat stress at different times of gestational age. So we wanted to try and take that into account in how we modelled the exposure. And we also thought we were trying to think of like, why would we see an impact in growth in infants? There'd been some preliminary evidence from the large DHS data sets to indicate that perhaps there was an increased risk with wasting, but why would that be happening? So this was our sort of theoretical framework as to what's actually going on in the biological pathways to explain that increased risk of wasting. And so that's the trial that we use, and that's just what the data looks like from ERA5. And so what we found was actually that the first trimester exposure was associated with a small increase in a reduction in weight for gestational age, Z score. And what was really interesting was that because this was a trial, we could then look to see if there was any impact of the supplementation. And there was evidence that those that were supplemented by protein energy supplementation actually did have an effect of heat, which we didn't see in those that were supplemented with micronutrients deficiency. Micronutrient supplementation. So as you can see, those with iron and folate, those with micronutrients, there's no effective heat, and those with protein energy, there is an effective heat. So our thoughts on this is very preliminary evidence, but could this be that protein energy supplementation increases your internal metabolic heat production, and then that in combination with your external heat pushes you over the limit to then put you at risk? Or could it be that micronutrient supplementation, iron and folate, protects you from the effects of heat, and therefore that's why you don't see it in those groups? What we did find, which is one of the first studies to look at it, was the impact of extreme heat on growth faltering in that first 2 years. And again, it depends on the age. The curves are slightly different depending on the age. But those around between 12 and 24 months, there is quite a clear indication that those exposed to higher levels of average heat stress had an increased drop-off in their weight for height, gestational age, so like the increased risk of wasting, and for their weight per age for gestational age. But interestingly, we did not see any effect on stunting, so that's height per age, Z-scores, and if anything, it seems to be showing the opposite direction in that case. So again, really interesting findings, not necessarily what we 100% expected, but starting to produce the epidemiological evidence of the harmful effects of heat that extend outside of pregnancy. And then finally, a stillbirth study that we've also not yet published, but just finalising. So this was using the case crossover analysis. I'm like going through all the different types, ways which you can do environmental IP studies. So this is a study where you take your cases and they act as their own case and their control. So you look at the heat exposure on the day or the day before they had a stillbirth, and you compare it to the heat exposure the week before or the week before that as their control. So that's how that sort of study works. And then you don't need to take into account any potential confounding because they are their own cases and controls. So this is the study from routinely collected birth registries. So a team went into the hospitals and flicked through the books to collect the birth outcomes, including termite-ridden books. Yeah, you can see here again this gradient, and this gives you the indication of where the health facilities are. There are some problematic methodological challenges with this, because obviously we assigned heat via the health facility versus where they lived, because that's all the data that we had. But despite that, we do see an increased risk coming out, and the places where there's a higher risk is the more inland places where it's hotter. So that's kind of the work that we've been doing to try and really build on what the environmental epi literature has to show around the impacts of heat in this setting, which up until quite recently was almost non-existent. But now I'm going to talk about our mechanistic work, which is, yes, maybe more of my passion. So this is one of our theoretical frameworks that we've developed around the both acute and chronic impacts. So we know that the impacts in heat maybe can take some time. If you're chronically exposed, it's going to have a different impact. Whereas if you are acutely exposed to an extreme heat event, then you see this increased risk of intrapartum stillbirth and preterm birth. Maybe we think is probably more of an acute effect. And these are kind of hypothetical because most of this is not yet being characterized in humans. And a lot of the data for this has come from animal models where they've done things to sheep and pigs and different mammals to look at the impact of heat in pregnancy. And why I think this is important is it's it's very hard for us to build the evidence-based interventions if we don't really understand the interventions. And I will give you a small anecdote on what one of the interventions that is always being talked about is drinking plenty of water in the heat. So one of my PhD students is particularly interested in this nexus between heat, pregnancy and disability. And she's just been doing some qualitative work on this. And she asks the women to describe what they do on a day when it's very hot and they're pregnant. And so this lady explains that, so she's in her room, tin roof, it's 45 degrees outside. She has to wait 2 hours for someone to then put her into the chair. She's then in her chair and outside, but it's still extremely hot. So she wants to take a cold bath. There's no piped water in her compound. She then wheels herself off down to where there is water, uses the manual pump to fill the bucket, carries the bucket in her teeth, wheels herself back to her compound and cools herself off with the bucket. So I think for me, the interventions have to be placed in the context of where we're based, and sustainable solutions have to take into account what is the daily life and reality of these people. So I'm going to talk a little bit about the first study that we did, which was started in 2019 before moving on to a larger study that we're doing. So this was based in Kenneba area, which is kind of in the middle, well, a bit close to the coast, but still gets very hot. And it's mainly subsistence farming in this area. And we were really interested in, at this point, trying to just even understand, is heat a real, is it an issue here? Is there any problems with it? Are they being exposed? And what does that then do to the mother's physiology? And can we identify if that then has any effect on the fetus? So this is an example from the study. This is Binta, who owns those rice fields behind her. They are her rice fields, previously used to feed the family for 6 months, but with climate change, that has now reduced to around 3 months because of the reduction in yield from the sort of changes in the climate. All of our participants were farmers or did farming or gardening, because that was the group we were particularly interested in. And you can see Jennifer travelling across the flooded rice field to take core temperature, tympanic thermometer measurement from one of our participants who's doing the transplantation of the rice. She's around 6 months pregnant at this point. So the study was based in this very subsistence farming area, and we recruited women, and then we went with them into the fields to understand what was their exposure. And we measured ourselves the heat that they were being exposed to, so that we had really clear evidence on what was the heat levels that they were being exposed to. And then we gave them different wearable devices to measure their physiology. And one of the main first challenges we approached was the fact that there is no real definition of maternal heat strain. Heat strain has been determined based on physiological studies of men, and they use this way of grading you where you combine heart rate and core temperature, and it gives you a score between 0 and 10, 10 being extreme physiological strain and 0 being none. And so there's nothing in maternal health to kind of really take into account. And is this going to work in pregnant women? Because we know that during pregnancy, your resting heart rate increases. So what do we do? So ultimately, we use that metric, but with the understanding that probably there needs to be much more detailed study to actually understand if there's a better way of measuring physiological strain in pregnancy. And I had some interesting discussions with my colleagues who are heat physiologists around the fact that pregnant women working in the fields could not have a rectal thermometer in place during their working shift. So we had to compromise, because that is not going to work. So that the gold standard for core temperature is rectal thermometer still. The alternative is a core telemetry pill, which you swallow. But we did not get ethics to do that, because at the point that we did this study, there was no evidence that it was safe in pregnancy. And so we used the tympanic, which we know is not brilliant, but better than nothing. And then the next question was, what is fetal heat strain? There's no definition of that either, and how on earth are we going to measure it in the field? So we explored using some of the more classic ways in which you monitor pregnancy, but these are all designed for around labour, so they're only really valid when you're above, I think it's 34, 35 weeks. This is a little mobile version of a CTG, but we were interested in early pregnancy as well, so we couldn't see how this could work for us. And it's not going to work in the field where people are bending over and doing manual work as well. So in the end, we decided to look at the umbilical artery Doppler, and that gives an indication of the uteroplacental insufficiency, so how well the placenta is able to function. And I used a small portable device that's been developed in South Africa, really easy to use, and you get this really nice signal if you get it in the right place, and then you get this nomogram, which indicates where they are, whether they're at high risk or low risk.
Sorry, can I? So is that something that they wear continuously whilst they're in the field?
No.
You go do it.
You have to do it. So so we did it. We did a baseline, midline, end line scans. And this is what it looked like in the field. Yes. Ideally, you would do something. You would have something that was continuous, but so we had the maternal continuous, but the fetal we did intermittent.
But it's still really cool.
And what we found was that the heat exposure was much higher than you would think when you look at the global gridded data, actually. So we were sometimes getting 10 degrees higher than what was coming out of that ERA5 land database. And if you look at this, which is the UTCI, these are two different indices for heat, there wasn't a single day where there wasn't moderate heat stress exposure in our cohort. Unfortunately, the study was slightly curtailed because COVID happened, so we had to stop in April, where we would have continued for a full year of recruitment. And we saw this very clear indication that there was increased risk to the women of physiological strain and increased risk to core temperature and skin temperature. So that's the core temperature and skin temperature, and then that's where we put the temperature and the heart rate together to look at the impact on the physiological strain. And then when we looked at fetal heart rate, again, we found this quite clear link between heat stress exposure and fetal heart rate. This is not including the mother in this. This is just looking at mother heat and fetus. And we began to kind of find potential evidence around a pathway. So this was, unfortunately, because of the COVID pause, we only had 40 women that we had evidence from the Doppler ultrasound scan on. But we indicate that perhaps those that then go on to have an adverse outcome, such as preterm birth or stillbirth, have a different reaction to heat exposure versus those that have a normal pregnancy outcome. But even those with a normal pregnancy outcome, there may well be a threshold of effect where the heat stress is so much that actually you can't physiologically compensate. And we do know that there's a point at which you need to take behavioural measures to protect yourself. And when we put it into the multi-level model, there was a clear link between heat exposure and, by however you wanted to define it, with the UTCI or wet bulb globe or just temperature, and the fetal strain, which was our marker, was that change in the placenta to show that it was inadequate or a fetal heart rate above 160. And then when we try to sort of look at the pathway between mother's physiological strain, again, there was a link, but there's obviously, even without the mother's strain, there was also a link between heat and fetal outcome. So indicating that maternal heat strain is a pathway, but it's not the only pathway impacted that we found. And alongside this, we did some qualitative work to try and understand what it really means for people's lives. And so climate impacts were very real. There were really feeling the effects, and there was a definite recognition that in the sun it is particularly challenging, especially when you're pregnant. And although people recognise what they need to do, as in take a rest, drink plenty of water, reduce the amount of work that they're doing, that's not always possible if there isn't the socio support around them to allow them to ease off on the work that they're doing. So now I'm going to talk about our ongoing cohort. So that was all work that's finished in 2021. And so this is a Wellcome funded grant looking at the pathophysiological mechanisms. So really building on that initial findings to try and understand in much more detail what's really actually going on with these women exposed, and not limiting ourselves to pregnant farmers, but looking at a much broader cohort of women. And the whole grant has 5 work packages. I am not going to talk about the heat chamber studies, but I'm very happy to talk about them at another point. But that was run by our collaborators at the University of Thessaly in Greece, and they put pregnant women in the heat chambers at different temperatures and got them to do different exercises and really interesting findings. But I'm going to tell you a little bit about the systematic review and maybe talk about our prospective cohort study. So from the systematic review, this is purely looking at mechanisms. So what do we know at this point around what are the mechanisms for association between heat exposure and adverse birth outcomes? And most of the studies from the US and China again, although there is a fair number that have been done in the Scandinavian countries, mainly around solar exposure. So that's Finland and Sweden, where they've done quite a lot of putting women in 70 degrees temperature saunas, so very interesting. But almost nothing from areas in the world where there is high exposure, even Southern Europe, nothing really as yet. Tropical regions almost entirely missing. That's our one study in the Gambia that's currently showing up there. And what we found was actually there was enough evidence from the systematic review to say that in both lab and field studies, there's quite a clear, obvious link between heat exposure and maternal strain. So there was both studies showed increased risk of increase in core temperature, increased risk of heart rate, and increased risk of fetal heart rate. But what there isn't really is hardly any data on inflammatory pathways, on hormonal changes. There's lots of theories that oxytocin release is impacted, antidiuretic hormone, and there's just nothing there. And there's a few studies that have started to look at placenta, blood flow, as well as epigenetic changes, but again, not enough that you could do any kind of meta-analysis on the findings. What was interesting is that there does seem to be coming out from the physiological studies that pre-eclampsia may be a particularly at-risk group. And this is also collaborated by the epidemiological evidence, which also shows that that is an at-risk group. And it's particularly interesting because when you think about our interventions being drink plenty of water, in pre-eclampsia, that can actually be quite dangerous and risky for that group. So it brings into confidence some of the sort of wisdom and what we do with that. Okay, I'm going to talk about the prospective cohorts, which is utilising that gradient that I showed across the country. And so recruits in 2 sites. One is at the coast in Brikama, and one is really far inland, the furthest inland you can get city, which is Basse. And the Brikama is more urban. Basse has an urban centre, but is also very rural. So we recruited from both urban and rural in Basse. And we, you can see here the sort of gradient in the different exposures. That's from the kind of weather station data from the 2 sites. So as I mentioned before, one of the challenges with this is around dating. So pregnant women in the Gambia do not get routine dating scans, and they often don't turn up for antenatal clinics until around 28 weeks. So we had to make some kind of compromise around the cutoff that we were going to take, wanting to get an accurate gestational age, but also acknowledging that if we make it under 13 weeks, we wouldn't recruit anybody. So we set on 26 weeks as a compromise, looking at sort of when people present to the clinic. We trained all of the staff. Everybody learned how to do ultrasound scanning. We brought the portable scanners into the country, and everyone got scanned at that point. And then going forward, once they were recruited, they were kept a close eye on by the field team. So they would go and visit them very regularly and ask them questions around well-being, heat illness, sleep, food security. And we would do these intense physiological monitoring sessions twice during the pregnancy, both at 28 weeks and 35 weeks. And that included giving them a wearable device that they then kept on for that entire time frame, and a little I'll put a picture of it later, and a little device to actually measure their exposure as well. And then at birth, we collected all of the birth outcome data. We collected placental samples, cord samples, maternal samples. And then postnatally at around 6 weeks, we did the neurobehavioral assessment scale assessment on the infant to try and start building the evidence about whether or not heat affects neurocognitive development in utero, which is a growing area of interest, but there's very little evidence on this as yet. So this is one of our little devices out in the field. So that's our mini weather station that's collecting everything that we needed. And this is what the participants wore. So that's the watch. That was a Garmin watch. And then they had a little Kestrel drop, which they pinned to their clothes, that then gave us the heat and humidity. And by that, we were able to then characterise their actual exposure. And so Dorothy is doing her PhD, the one I mentioned, who's particularly interested in disability. So the other part of her PhD is around the environmental mapping. So she looks at the stationary data that we have, and is going to use machine learning to then apply that to the individual pregnancies using the ground truth of the wearable device that they wear during their few weeks of monitoring during their pregnancy. And this is the different stationary devices that we have. So you can see the big peaks is coming from the hot area inland, and the more sort of stable is the cooler coast, although it's not actually that cool. And then when we look at the individual level data, again, that's reassuring for us. It follows the same pattern where you see this big peak of exposure in those that are living in the hot inland area, and much smoother, less extreme peak in those that live at the coast. So there's around 135,000 hours, of individual level data from the that drop device. There'll be much more data available from the watch, because that was measuring every 15 seconds. So the idea is that we will be able to characterize many of the sort of, I guess, unanswered questions, thinking about mechanisms and impacts in this setting. So we want to look at how heat interacts with heat strain and then pregnancy outcomes. We're really interested in how sleep and sleep quality is impacted. There's evidence from a global study that as you increase your temperature exposure, you decrease your number of hours that you get of sleep, and women and low middle income countries are particularly affected by this association. There's a growing interest in the impact of heat on well-being. We kind of tried to broadly capture that by using the WHO 5 well-being score, which we ask at multiple time points. There's an unanswered question around domestic violence, which I think would be really interesting to kind of look at in more detail, but that's not the remit of this study. And then the placenta and inflammatory biomarkers is all going to be run by our collaborators in Cambridge to really try and unpick some of those changes. So that's the team. And we just finishing the last of the NBAS this month. So that's very exciting. We're going to be finishing data cleaning and start our preliminary evaluations of that study. And then I just wanted to mention two more studies, but before I finish and open for questions. So this is actually the project that's run by the University of Bristol from the School of Engineering. And it's around energy transition and how to transition to a low carbon energy in sub-Saharan Africa. And we're calling it the SHINE project. And it's around how to equitably and holistically approach the issues around energy access. And the idea initially was to use existing mini grids and then tap into those mini grids and then decide on an intervention that was determined by the community. We would facilitate that. We would evaluate it in a pilot randomized control trial or something, and it would give us a framework for how these sorts of interventions should be done going forward. And the sort of key issue that we wanted to focus everything on is around well-being. And it has been more complicated than initially thought, because the mini-grids do not support the e-cooking needs. So I don't know if this is, it's really, really interesting to see how houses in these settings can be amazing spec, you know, can be beautifully tiled inside, but the kitchen will still be 3 stones with wood at the back. It's the last thing that anyone does anything to, and it's the least prioritised change. And one thing that has been increasingly interesting for me is this intersection between extreme heat and cooking. And actually, one of my nurses on my study was describing how one of our participants, quite young, on her first pregnancy, she was cooking the afternoon meal. So full sun, no shading in her area, cook outside. She's cooking, and often the cooking takes between 3 to 4 hours because you cook for a large household. And at some point during that, she felt her abdomen tighten dramatically and she felt very unwell. So she tried to call for a taxi, but it was the rainy season, so the taxis won't come. So she called for us, and part of the way in which we set up our studies is also to try to ensure that we deliver care where we can. So we sent our driver and car to pick her up. They brought her in, and the nurses who initially evaluated her, because she stays under the government-run service, basically just accused her of taking something, and she subsequently went on to have a stillbirth. So there's a lot of I would say compounding impacts that kind of come together to make people's lives hard. So access to healthcare, this multiple different factors bringing together. And I often think of heat as being the straw on the camel's back. So it's not usually the most important thing, but it maybe is the tipping point. So for me, I think cooking is a really interesting area that it links very nicely into heat. Maybe not immediately, but and we've just put the trial through ethics, so it should start within the next few months. And then the other aspect that I haven't really touched on is around access to care and kind of considering how climate events maybe affect how people can then get to the care that they need. And so this is a project that's also funded by Wellcome that is looking at how extreme climate events, so not just heat, but also flooding or extreme rainfall, may impact on the ability for women to access antenatal and postnatal care. And we're based in the Gambia and Senegal, and we're just kicking off this study, but it will involve, one of the complications of this is obviously there isn't any digital health record. So we will be going to the books. We're looking through the books to see if there's any indication that less women can arrive on a certain day, and linking that back to the sort of climate exposures, with the idea that that will then be able to inform policy of where potentially where they need to consider extra care, or where they want to perhaps build a new healthcare service, or potentially support women in those particular times that are coming up. And within that project, there's also a kind of key policy angle to it, and a key co-design with the population as well. And that's it. Thanks very much.
Wow, that was amazing. Thank you very much. Questions? I'm feeling quite emotional. Sorry. Questions from in the room or outside? Kate.
No, fascinating and amazing work. We've been kind of trying to start some work in the country by a project that didn't get funded, looking at women's health and heat. One of the things that we were thinking about was what are the pros and cons of using the sort of community measure of heat versus the individual one? Because obviously the community one gets over some of the confounding, and the individual one gets you more precise measures. I don't know what your thoughts are.
Yeah, it's tricky. So all of those studies that I presented at the beginning about the EPI data are all based on like community level allocation of heat exposure. I'm hoping that our study will basically show that the individual measurements are pretty much the same as the stationary devices, and then we can just go, okay, well, stationary devices are fine. But I don't know that yet. And one of the things that I think is important is indoor heat. And I think especially in the UK, I mean, the Gambia is a bit different because people do spend a lot of time outside. So actually the outside heat maybe is accurate, but indoor heat is so variable by building structure and building site. I haven't talked about one of the other projects that I'm involved in, which is around structural interventions in Pakistan. And that is like putting in shading, putting in different things to try and cool the indoor environment, because in Pakistan, women often spend a lot of time indoors as well. There is a project, Magenta, the project in Swansea. They are looking at in detail indoor heat exposure, I think, for Wales and maybe. But yeah, it's really interesting. Hopefully in the next couple of months I'll be able to tell you if it's okay.
Because here it's very confounded, because depending on your house style.
Yeah.
Whether you have to go out to work or whatever.
Yeah. And then, fuel prices have gone up, and we know that actually here the cold effect is also very strong. So, yeah.
I guess indoor cooking is also related to indoor air pollution as well as heat.
Yeah, absolutely.
Other questions? Celia.
Hi, thank you. Thanks, Anna. That was really interesting. I just wondered, do you see any evidence in the Gambia of kind of intergenerational learning, like older women assisting younger pregnant women with heat? Or I'm just wondering if there's any learning around how to manage the environment from older people in communities. Have you seen any evidence of that?
Actually, I think we've seen the opposite.
Oh, really?
Not necessarily the opposite, but when we look at we've done some preliminary evaluation of our wearable device data, and it seems that the older women are a bit more protected from the effects of heat because they have younger kids that can do stuff for them. They potentially have more power in the household, whereas the younger women, when you look at the sort of classic kind of increasing heat, you should reduce your energy expenditure. They can't do that. The younger women are unable to do that because they still have all of these commitments to the household. And that was also kind of what came out of our qualitative work kind of a couple of years ago, where younger women particularly seem to be unable to advocate for themselves to make those behavioural changes. And there's been a couple of very interesting health beliefs that we've tried to kind of push back against, but I think still needs a lot of work. There's this real, very firmly held belief that if pregnant women drink cold water, you are then going to cause pneumonia in your baby. And so that's was quite interesting. And we push back every time we talk about it. And the other belief was that if you sit in front of a fan when you're pregnant, you will, I think, alter the amniotic fluid. So actually, the behaviours are like the opposite. So there's an NGO at the moment who's doing a big campaign up the whole of the Gambia that we're supporting around education for communities and healthcare workers. But it's definitely sort of on our agenda as the sort of next things that we need to try and address.
Yeah, I often think that some of the behavioural interventions that get developed are very kind of, with a kind of high income setting. It's very much about the mother, maybe the partner, but not really about the household. But I think it's a different context in African settings where you have to do a behavioural change within a household, not necessarily at an individual level.
Yeah, absolutely.
Interesting. Thank you.
Questions, comments? Yeah.
Just wondering, do you have solar exposure as well? Do you have any measures of like their exposure to the sun?
That's slightly weird looking device. This one.
Right.
That the black globe is
Right.
measures the black globe temperature. So yes, for the stationary devices we do, but for the individual drop devices, it's just temperature and humidity. So yeah, we don't have solar. And on the first study that I did, it was also a similar portable device that did also measure solar radiation. So, and that was when I discussed it with climate scientists, that was their thoughts as to why we were seeing such high temperatures, was because actually they're farming, they're in the direct sun. So we're actually measuring that, and that's why we're seeing such high temperatures. Whereas when you kind of take the average across the whole grid, then the shade will kind of even it out a bit more. Yeah.
Other comments, questions? Great questions. Hi, Winfred.
Hi, I have a quick question around the solar power project. I'm just thinking about the fact that the Gambia just contribute about 0.01% of the greenhouse emissions, and I'm wondering, how are you going to really measure the impact of the solar power project? But also just thinking, if you're going to transition to using that to e-cooking, what are some of the plans around infrastructure to just make sure that you've got enough power to actually be used for cooking for those large households, as well as the people tend to cook hard food, so it takes longer than what we have here. So yeah, just want to hear your thoughts around that.
Brilliant questions, are very, very important. I think that's why it's taken us about a year to actually start doing anything for the project. So Gambia does not contribute anything to climate change. However, the way it gets energy at the moment is from an oil tanker that sits off the coast. It's full of heavy oil that then gets fed into to generate the energy. And so it is obviously current events show how precarious that situation is, and renewables are a good option to help build climate resilience going forward. So I think it's not so much about reducing their emissions, it's more around trying to stabilise and kind of improve the energy access and energy supply. So even with that oil tanker, there's still multiple power cuts throughout the day, and especially during the very hot season, can be very long power cuts at the time that you really want to stay cool, and it's then very difficult for everybody. So I think that's kind of part of the argument to try to build the infrastructure around renewable energies in that setting. To speak to your second point, the Gambian government is actually, I think, well, it was, I'm not sure if it still is, but it was the only government in the world that had NCDs that were, the commitment to greenhouse gas emissions that was in keeping with us staying under 1.5 degrees Celsius. And so there is a massive commitment from the government around this. And they have actually commissioned solar farms across the Gambia, and they're all just starting up right now. So it feels like quite a timely project because there is a big drive to push these mini grids out there. That said, the mini grids that are out there have been are under sort of somehow under capacity for what's needed in the community, and so perhaps this project will highlight that. And then, since they're at the point of building these grids, the battery storage, etc., it will help to inform them going forward. One of the things that we found when we went to, so the project is based in Gambia and Ghana, and we went to Ghana last year for a visit, and they've done an amazing job of rural electrification. And so we went to some islands off the River Volta, and they have the mini grids in place, but they're pretty much only used for lighting. And so then the batteries are just full all day long, but no one's really using them because there's other challenges. And so just putting a mini grid isn't the solution, which is, I think, what this project is trying to address, that actually there's many other aspects that need to be considered going forward. Hope that answered your question.
Yes, it does. Thank you.
Yeah, I got a question about, I was more interested in the kind of the research that you're doing, like the mechanistic people. And you were saying most of it is animal research. So you just, because I remember, I forgot her name, but she was looking at cockroaches and
Yes.
Yeah. So are you like looking to then translate maybe from like an animal study to human study, or?
I don't do any animal work.
Okay. Yeah. So you were trying to extrapolate also.
So yes, we kind of like looked at the different pathways that had been identified in the animal literature, and then applied it to the humans, then tried to test it.
Yeah.
But there is the group that got funded. This call is funded by. There were 11 projects that were funded by Wellcome on the same call. I think 4 of them are animal studies. So there will be. And they can do all sorts of crazy things for those animals. Obviously, you can't be pregnant. But how directly translatable is the issue. So I've much as I respect the work, I find I'm like, okay, that's good. Gives us some basic science information, but we obviously have to adapt it when we think about human.
Yeah, with Sinead's cockroaches, I know she's got amazing grants to sort of learn some epidemiology. It is trying to compare it with what we see in babies as well, in human babies.
Yeah, exactly. I had a quite confusing conversation with my collaborator in Cambridge who does lots of work on mice, and she was talking about irradiating the mothers and this and that, and I was like, oh, how do you work on this?
Other comments, questions?